remember that the graph is up and to the right if it's an original, correct? So we said the original function without any transformations literally looks like that. We agree? So if it's up and to the right, there's no translation, no transformation. The desk is really messed up. If you want to give her once, she can make it an extremely long line. Just pull that back. All right. So up and to the right needs no reflections. We agree? So if you look at this first one, it's a +2 and a +2. Is there any reflections on it? No. Now if we actually had to draw it, we have to do mapping and do way more, but we're matching. So which one is still up and to the right? B. So this is little a. Or we just put a capital B beside this one, right? Okay. Let's look at B. What type of reflection do I have here? Reflection in the x-axis. So now instead of up and to the right, it's still going to be to the right, but now it's going to be down and to the right. It's going to reflect in that y-axis. It'll make it go this way. Yeah? So which one is down and to the right? C. So C, or we could say a little b. Right? Now, this one has a reflection where? In the, with the x, so it's in the y-axis. So instead of it being up and to the right, it's still going to be up, but to the left, because it's going to reflect in the y-axis. It's going to go that way, right? So up and to the left is D. Little C for this one. And then the last one has two reflections, reflection in the x and reflection in the y. So it's going to reflect. So it's going to, instead of being up and to the right, it's going to completely be down and to the left. Yeah? Which is A. So for these ones, because everything else was the same but the reflections, we can look at those. We agree? All right, next page. Okay, radicals are special functions. If you get a radical, you should be happy. Because normally, when we come up with an equation of a graph, we have to do the stretches, reflections first, then the translations last, right? Remember, we have to apply the stretch and the reflection first, and then we have to see, once we apply those, how far are we now from that endpoint, correct? Put that away. Went into my mean over voice. Put that away. It dropped like 4 octaves. Didn't even mean to do that, but that just really happened. All right. I don't have a very feminine voice to begin with, but then I dropped it like it was hot. Stop. No. Do you know? See? It's scary. All right. Oops. Okay. So, what's the only thing that can move an endpoint on a radical graph? Because radical graphs are special. Horizontal translations and vertical translations, but why? Where do they normally start at? 0, 0. So your radical graph, your square root x graph, the parent function of that, will start at 0, 0. We agree? And the only thing that can move it off of 0, 0 when I talk about transformations is translations, the horizontal translation and vertical translation. Because the coordinate is 0, 0, stretches and reflections multiply, correct? And multiplying by 0 does what? Nothing. So the only thing that can move those is our vertical and horizontal translations. This only works with radical graphs and quadratics. Why would it work with a quadratic graph? Where's the vertex on a parent function of a quadratic graph, on a basic x squared graph? It's at 0, 0. So the only thing that can move that vertex is horizontal and vertical translations. Okay? So it works with quadratics, an x squared graph, and it works with radicals because they start on that 0, 0 point. And so the only thing that can move them is horizontal and vertical translations. We agree? So what kind of translations did this graph do? Horizontal translation what? For right. Is this correct for me to write it like this if this was a written response on a test? No. If it's for my notes, can I do that? Sure. No one's marking it. Okay. Vertical translation what? 1 where? 1 up. I'll write the P because it's only 2 letters. Okay. We agree? Because this is 4 to the right and 1 up. That's how we got there. So the translations are really easy on a radical graph and a quadratic if you move the vertex of the quadratic, right? Okay. Now we have to talk about stretches and reflections. Does this thing have any reflections? We just discussed reflections above. The graph, if it's up and to the right, it's good, right? It hasn't been reflected at all. What is this graph? Up and to the right. So has there been any reflections? No. So I'm going to write no reflections to remind myself. Then I have to talk about stretches. This is the key thing. Between the first point and the second point, there's more. There's more than 93. But what I'm only really looking at is this first and second point. Between the first and second point, I make a 1 by 1 box, correct? So if between the first and second point I make a 1 by 1 box, there's no stretches. Okay? So I could go 1, watch this, I'm going to erase it right away. I could go up 1 and over whatever the heck that tiny little fraction is. Is that easy to figure out, that one? No, so instead of going up 1, I could do the opposite. I could go right 1 and up how many? How many did I go up? 3. So it's not 1 by 1 this time. It's a 1 by 3, correct? So what type of stretch is that? Vertical or horizontal? Vertical. So vertical stretch 3. Yeah? I'm going to show you how you can get the horizontal stretch as well. So there's 2 equations I can make out of this because it's a radical. Ready? So we're going to do the basic one. So we're going to have y equals, if I apply these to the equation, what am I going to get? Y equals, what number is going to go here? 3 square root, what? X minus 4. Do I need brackets if it's just x minus 4? No. I just kind of went a little overboard. And then plus 1. Now the thing about radicals and quadratics is I can take that number and I can actually put it inside and make it a horizontal too, can't I? Grade 10. We're going to go back to grade 10. So this is one option. The other option, if I take that 3 and I put it inside the radical, what would it have been? 9. Because 3 bring it inside is a 9. Square root of 9 is 3, right? So if I want to take this now and plop it back inside of here, I have to square it to put it back under the radical because I square rooted it to get it out. Yes? So they could also give the answer 9 x minus 4 plus 1. Now what horizontal stretch is that? Not 9. It's a horizontal stretch by a factor of 1/9. So remember how I said, hey, I could go up 1 and over till I hit that? That's 1/9. It's up 1 and over 1/9. Would anyone get to 1/9? Are you going to guess that that's 1/9 over? No, I'm not going to, ever. So I'll do my vertical, and then I can put it back inside to make it enough. Okay? So you do whichever one's easier. Sometimes going over 1 and up how many is easier. Sometimes going up 1 and over how many is easier. So we'll look at the next one. Okay, B. Let's get our translations first. Can we always get our translations first? With a radical, yes. For any other function, no, you have to do stretch and reflect first and then see how you move it, okay? But for a radical, you can always just find those because it starts at 0, 0. So it's normally here. It's now what? 2 down and 3 what? It's now 2 down and 3 what? 3 left. So we have a vertical translation, 2 down, and a horizontal translation, 3 left. We cannot use short form. We only can because it's not asking me for my transformations, right? So that's not a necessity. Okay, then let's discuss reflections. Is this thing reflected at all? It's up and to the right. That's where it is if it's no reflections, right? So we have no reflection. Let's talk about stretches. So would this one be better to go up 1 and over this weird amount? Or would it be better to go over 1 and up a normal amount? Over 1 and up a normal amount, correct? So this one, the easier one to do is a vertical stretch of what? 2. Because it's a 1 by 2 box. So it's a vertical stretch of 2. So my equation is going to be y equals 2 square root x plus 3 minus 2. Or, what equation could they give? Y equals square root what? 4. And then what do I have to make sure I do? Bracket x plus 3 minus 2. Okay? You guys try C and D. So, this one, we can talk about translations. Now, guys, please, everyone's paying attention to me. Do translations, there's too many phones out. Translations, can I find them first always? Is that a thing you can always find first? On a radical graph, yes. On any other graph? No. The only other one you could do is an x squared graph, yeah? Because they start at 0, 0. So this one, so please don't go doing the translations like this on every other unit now because you did it for this one. This only works for radicals, okay? So this one is a horizontal translation 2 right, vertical translation 3 up. Is there a reflection? Is it up and to the right currently? No, it's still to the right, but it's down. So what type of reflection is that? It's down now. So it's a reflection in the x. And then our stretch is over 1, 1, 2, 3, 4 vertically. It's a 1 by 4 box. So a vertical stretch by 4. So we're going to get y equals 4 square root x minus 2 plus 3. And then I need a reflection in the x. So it's a negative 4. We agree? Can that negative go inside the square root? No. If you bring it inside the square root, you make it squared, and then you'd get rid of the reflection, and that's not going to work, right? So what could I bring inside? The number, not the negative. So I'm going to get y equals negative 16 x minus 2 in brackets plus 3. Now some people say to me, Mrs. Lepp, what if both of them are there? Can they make both of those answers be in the multiple choice? No, they both give you that graph, so that would be stupid. So they won't be both there. Okay? Done. All right. This one has a horizontal translation 3 left, a vertical translation 4 down. You can only do short form because this is not on the test. It's down and to the right, so we still only have a reflection in the x. And a vertical stretch, so we go over 1, it's a 1 by 2 box, so vertical stretch by a factor of 2. So we get y equals negative 2 square root x plus 3 minus 4, or y equals negative 4x plus 3 minus 4. Okay, we do number 5. Go. So the first one, we have a half and 6. We always look and see. Sometimes the equation that we're comparing it to already has some stuff on it. Sometimes it has like a stretch already on it or a translation already on it. So you don't just state what's there. This one is just the parent function. There's nothing on it. So we're going to just try the transformation. So we're going to say it has a vertical stretch by a factor of what? Yeah, of 1/2 about the x. So no short forming it, and you need to actually write the transformations out. And then we have a horizontal stretch by a factor of what? And 6 about the y-axis. Okay, write a function equivalent to 1/2 root 6x in the form a root x. How can I bring that 6 out? What do I do to it? because they want it all in front. When I put it in, I squared it. How do I take it out? Square root it. Is square root of 6 a nice number? No. So are we going to just leave it square root 6? Yes. So we can go 1/2 square root 6 square root x. So technically, it's the square root of 6 over 2 root x. Is it not? Does it have to be pretty? Most people would say that is pretty in mathematical terms. Not in your world. So what is it? It's just a vertical stretch by a factor of what? 6 over 2. That's it. Vertical stretch by a factor of 6 over 2 about the x-axis. Now they want the whole function underneath the root. Okay, how do I get that half to go underneath? Square root it to bring it out. How do I bring it back in? Square it. Grade 10 was taught this, right? Grade 10 you were taught how to make mixed radicals and entire radicals for this very moment in time. You didn't know it. You're welcome. All right. So we get y equals 1/4 times 6x, which is 6 over 4, which is actually what? 3 over 2x. Remember, if you get stuck with fractions, put the basic one over 1, and then across top, across the bottom, right? Numerator, numerator, denominator, denominator. So now I have a horizontal stretch. By a factor of 2/3 of y. Yeah?
Whoa.